So we're going to sketch a few more angles in standard position from radian measure. And in exercise 18, we're going to sketch pi over 6, 5 pi over 6, negative 7 pi over 6, negative 13 pi over 6. These are all multiples of pi over 6. And we know that pi over 6 is just another way of saying 30 degrees, right? We got to keep pi over 6 and pi over 3 straight. Pi over 6 is 30 degrees. And because each one of these can be thought of as a multiple of pi over 6, I'm just going to pull out a diagram here where first I'll show you the multiples of 30 degrees, or a full circle sliced into 30-degree pizza slices, right? So you can add as you go around, right? 30, 60, 90, 120, 150, 180, etc. If you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 copies of 30 degrees gives us 360. Or when you slice this standard position picture into 30 degrees, notice that each quadrant has 3 copies of 30 degrees. So there's 3 in the first, 3 in the second, so on and so forth. So this kind of picture can help you count multiples of 30 degrees, and that's exactly, that corresponds to multiples of pi over 6 when we're working with radian measure. So we can count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, so on and so forth. But we want to be thinking in terms of this way in which the full circle is cut up into pi over 6 slices. So let's go ahead and do these now. First, pi over 6. Now again, you don't have to do it super accurately, but you want to know it's certainly less than 45 degrees, right? So pi over 6, terminal side, and the first quadrant, same as 30 degrees. 5 pi over 6, I got to think about a little bit. If it helps you, you can imagine those 30-degree slices. So 30, 60, 90, 30, 60, 90. So we go around. And that makes it easier for me to count. 1, 2, 3, 4, 5 pi over 6 is going to be right here with terminal side in the second quadrant. So it's the red lines are not really relevant or necessary. You can leave them off. It's just the blue, it's the terminal side that's most crucial, because we know the initial side is always going to be the positive x-axis. And realizing that we end up in the second quadrant with that terminal side is crucial. Let's do negative 7 pi over 6. So again, eventually you should be able to just imagine these red markings without having to draw them in, because I think it is sort of clutter. So negative 7 pi over 6, I have to go in a negative direction. So negative 1, 2, 3 pi over 6, negative 4, 5, 6 pi over 6. Negative 7 pi over 6, that's the same terminal side as the one we just did. Exact same position, right? As 5 pi over 6. And negative 13 pi over 6. I'm actually going to try to draw this without putting the red marks on. It's another negative angle. So I'm going to go negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12 pi over 6 is full circle, right? And I want to go another negative pi over 6 beyond that. so it's like 30 degrees below that positive x-axis, is where I end up with. And it's not so much where you write the number for the angle. You got to get that curve in there with the arrow indicating, because that helps us see whether it's positive or negative. And we went more than full circle, and the terminal side is in the fourth quadrant for that negative 13 pi over 6. Okay, one more type like this we're going to look at is exercise 19. These are some multiples of pi over 3. So pi over 3 is the other special angle that in degree measure is known as 60 degrees. So we want to, again, be able to keep pi over 3, pi over 6 straight. And it's really going to be just a similar kind of maneuver here. And I'm looking for my sheet with pi over 3s on them. Here we go. Sorry. I just wanted to bring up this picture of multiples of 60 degrees. And there's one little bit of trickiness you got to watch out for when you count multiples of 60 degrees. Because when we go 60, 120, 180, etc., we miss the y-axis, both the positive and the negative portion with terminal sides. So, one copy of 60 lies here. 2 times 60 is 120. We hop over the y-axis. 3 times 60, 180. We land on the x-axis again, right? Then 4 times 60, 240. 5 times 60 is 300. We miss the negative y-axis. And then we land, but we do land back on the x-axis. So when you count by multiples of 60 degrees, you just got to be careful not to accidentally stop on the y-axis, because that is not encountered by the terminal sides here. And so the same way of thinking works with multiples of pi over 3, okay, because we're trying to think in terms of radian measure now. Okay, so let's go ahead and do these. So pi over 3 is 60 degrees. So its terminal side is in the first quadrant. And that's just an approximation to pi over 3. 2 pi over 3. Now I'm going to go back to my little picture here. 2 pi over 3 is already in the second quadrant, right? So the second copy of 60. It's sort of like 30 degrees beyond 90, right? So there's 2 pi over 3. Seven pi over 3, I'm going to try to count multiples of pi over 3. If I put lines to help me, I would just put one line here, and then notice we land on the x-axis, but we don't land on the y. So you just got to be careful with that when you count by multiples of 60 degrees or pi over 3. 1, 2, 3, 4, 5, 6 is full circle. So 7 pi over 3 takes me to that terminal side of 60 degrees, same as pi over 3, right? 7 pi over 3. And now we got to do negative 11 pi over 3. So again, this guy makes it easy if I do negative 11, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just short of negative 12 pi over 3 would be 2 full negative rotations. So I'm going negative direction, just short of 2 full rotations. That's the same terminal side as pi over 3, negative 11 pi over 3 has terminal side in the first quadrant. So if I counted negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11 pi over 3. And all right, we still got one more video of this type of stuff, but I'm going to leave that for another video, right? So stop here for now.